This is the problem that appeared in Indian National Mathematical Olympiad 2008. So this is the first problem on the test, and the problem is from geometry. So the trick to solve any geometry related problem is to make a good looking diagram after going through all the information that is provided in the question. So let us go through the question. I have made a rough diagram here. Let us go through the question and understand what is given in the question. So let ABC be a triangle. So we have a triangle A, B and C, and I is its incenter. So this I is the incenter of this triangle ABC. A1, B1, C1 be the reflections of I in BC, C and AB respectively. So we have to take the reflection of incenter in each side. So the reflection of I in BC is A1. So let this point of intersection be D. So since we are taking reflection, this angle will be 90 degrees. And similarly, let this intersection point be E. This is 90 degrees. And B1 is the reflection of I in AC. Similarly, C1 is the reflection of I in AB. And this is 90 degrees. Let this intersection point be F. So now, since I is the incenter, ID will be in radius, that is equal to IE. IE is also in radius, that is equal to IF. So since we are taking reflection, ID will be is equal to dA1. So that is equal to dA1. So this will be is equal to EB1. This will be is equal to C1F. So all these things will be R in radius. This is in radius, this is in radius. Since this is in radius and this is the reflection, this is also R. So far, with the given information, we are able to see this much information. Now, let us analyze further. So we'll go through the rest of the question after a little bit, and after analyzing this much information, we'll read out the next part of the question. So now if we see IB1 is equal to IA1 is equal to IC1 is equal to 2R. So I is equidistant from A1, B1 and C1. So a point which is equidistant from the vertices of the triangle is circumcenter. But so I is equidistant from the vertices of the triangle A1, B1, C1. So I will be circumcenter of triangle A1, B1, C1. So I is the center of this triangle which passes through A1, B1 and C1. Fine. Now let's go to the next part of the question. Suppose the circumcircle of triangle A1, B1, C1. So this blue circle passes through A. So it is passing through A. So we made the diagram such that this circle passes through A. Fine. Prove that B1, C1, I1 are concyclic. So we have to prove these 4 points are concyclic, right? So before analyzing the question further, so let us discuss some techniques to prove the concyclicity of 4 points. So there are generally there are two techniques which we use to prove the concyclicity of any 4 points. The first technique is, let us say you have 4 points on a circle. Let's 4 points on a circle. So if you are able to find out opposite angles, let's say alpha and say 180 minus alpha. If you are able to find out opposite angles and their sum is 180 degrees, if you are able to prove that the sum of opposite angles in the cyclic quadrilateral is 180 degrees, then we can say that our points A, B, C, D are concyclic. The next technique which we use is, let us say there is a chord AB. So this chord subtends equal angle. There is a property in circles. Any chord of a circle subtend equal angles at any point on the circumference. Let us say there is a point C on the circumference. So this AB subtends equal angles at C and D. So this will be alpha, this will also be alpha. So this is one more property. So in any question, if we are able to prove that any chord subtend equal angle at two different points, then we can conclude that those 4 points are concyclic. So now so with this information, let us proceed and solve the question. We will use this second technique in this question. All right. So we'll use this second technique. So what do we have to prove? B1, C1, I1 and I are concyclic. So this is your segment, line segment B1, C1, and here you have I and here you have I1. Let us say B1, C1 subtend an angle alpha at I, and this B1, C1 subtend an angle beta at I1. So what do we have to prove? That alpha is equal to beta. If we prove alpha is equal to beta, then it is as good as proving B1, C1, I and I1 are concyclic. So we have to prove alpha is equal to beta. So let us proceed to the question. So what is alpha? Alpha is the angle subtended by B1, C1 at I. So here we have I, and the angle subtended by B1, C1 at I is this. So this is alpha. All right. So now we have to find out alpha. So to do that, let us join A and I. All right. If we join A and I, AI will be, since I is the incenter of triangle ABC, AI will be internal angular bisector. So this angle will be A by 2. So in triangle AFI, one angle is A by 2 and the other angle is 90 degrees. So then this angle in triangle FIA, angle FIA is equal to 180 minus 90 minus A by 2. That is 90 minus A by 2. Similarly, if we consider triangle AIE, angle AIE is equal to, so this angle is also A by 2. The triangle AIE is equal to 180 minus 90 minus A by 2. That is 90 minus A by 2. So now we have to find out alpha. Alpha will be sum of these two angles, correct? So alpha is equal to 90 minus A by 2 plus 90 minus A by 2. That is 180 minus angle A. So we found out that alpha is 180 minus angle A, correct? Now one more thing. So I is the circumcenter of triangle A1, B1, C1. So here we have C1, B1 and A1. So I is the incenter of ABC but circumcenter of this triangle A1, B1, C1, and we know this angle. So there is a circle passing through this. I is the circumcenter and we know this angle. So then this angle will be half of this angle, right? This is the property in circle. B1 IC is equal to 2 times of angle C1 A1 B1, correct? So the angle at A1 will be alpha by 2, correct? So this is the center of the circle. This is the center of the circle. This is the center of the circle, and at the center we have angle alpha. So at the vertex on the circumference we have angle alpha by 2, correct? Now what we have to do, we found out alpha. So now we have to find out this beta, correct? Beta is the angle okay. For that, let us make one more diagram. This is angle A1, B1, C1. correct? So this I1, what is beta? Beta is this angle, right? Beta is the angle subtended by B1 and C1 at I1, and I1 is the in-center of this triangle. So this angle will be B1 by 2, this will be C1 by 2, correct? So what is beta? Beta will be 180 minus B1 by 2 minus C1 by 2. Beta is equal to 180 minus half into B1 plus C1. So now we have to find out B1 and C1, these angles, correct? We already found out A1. What is A1? A1 is alpha by 2. A1 from this, A1 is equal to 90 minus A by 2, correct? Similarly, if we do the same analysis, let us say this has some alpha 1 and this has some alpha 2. Similarly, if we find out alpha 1, B1 will be half of alpha 1, C1 will be half of alpha 2. So here we already found out A1. So similarly, B1 will be 90 minus B by 2, C1 will be 90 minus C by 2. Okay, carry out the similar analysis. The similar analysis we use to find out alpha. So we will find out this B1 and C1 also. So now substitute B1 and C1 here. Beta is equal to 180 minus half into, what is B1 plus C1? 180 minus B by 2 minus C by 2. So this will be beta is equal to 180 minus 90 plus B by 4 plus C by 4. Beta is equal to 90 plus 1/4 of B plus C, but B plus C is 180 minus A. So 90 plus 45 minus A by 4. 135 minus A by 4. Beta. This is beta. So we found out alpha. We found out alpha here and we found out beta here. And according to our question, we have to prove this thing, alpha is equal to beta, correct? Now to do that, we have to find out angle A, the value of angle A. Let us do that now. So we already proved that I is the circumcenter of A1, B1, C1. So since I is the circumcenter, so the distance AI will be 2r. AI will be 2r. But what is, so A is the angular bisector and I is the incenter. What is the distance between A and I? So if we have a triangle and incenter I and there is a vertex A, what is AI? AI will be r cosecant A by 2. R cosecant A by 2. But according to this problem, that AI will be 2r because IB1, IC1, IA1 is 2r and it is a circumcircle and A also lies on the same circle. So I is the center of the circle and IA will be is equal to IA1, IB1, IC1. So IA is equal to 2r. So cosecant A by 2 is equal to 2. That means sin A by 2 is equal to half. So A by 2 is equal to 30 degrees. So A is equal to 60 degrees. If you put A is equal to 60 degrees in this equation, beta will be 135 minus 60 by 4. That is 15. Beta will be 120 degrees. Similarly, put I is equal to 60 in this equation. Then alpha will be 180 minus 60, 120. So alpha is 120 degrees, beta is 120 degrees. Alpha is equal to beta is equal to 120 degrees. What do we have to prove? To prove B1, C1, I and I1 are concyclic, we have to prove alpha is equal to beta. And we proved this. We proved it. Alpha is equal to beta and that is equal to 120 degrees. So B1, C1, I I1 are concyclic. Is it clear? So the trick here is to draw a neat diagram and do a proper angle chasing. So you have to chase all the angles, find out the angles and use the property of a circle. So this is the solution of this particular question.